Welcome to Class Connect Study Series with Yusuf Arikivia. Today we shall be looking at the velocity time graph. In our last class, we looked at the equation of motion. Another way of solving motion-related question is to use the velocity time graph. The velocity time graph is a graph of velocity against time. It is also a pictorial representation or the description of a journey. It specifies when an event occurs and how it transcends in an interval of time. It should be added that the slope of a velocity time graph gives information about the acceleration of the body in motion. Pictorially, we can represent a velocity time graph as shown below. As we pointed out earlier, the velocity time graph is a graph of velocity and against time. And from the graph shown, we can see that on the vertical axis we have v in meter per second, that is velocity in bracket meter per second, and time in bracket s, that is time as an SI unit of seconds. On the first slant that goes this way as pointed out, this slant shows the acceleration, or it gives information about the acceleration of the body in motion. Then we have a point that goes straight without bending. This point, as indicated, is the point that gives information about the uniform speed or the uniform velocity of the body. And lastly, we have the point known as the point of retardation or deceleration. And this portion tells us information about the vehicle or the body coming to rest. Now, a velocity time graph usually indicates when the body started, as in this case, the body started at the point O, that is from the origin, when the body started from rest. Let's take another example. In this particular velocity time graph, we can see that we have decided to separate the velocity time graph into three different regions, tagged region A, region B, and region C. Several information can be obtained in the different regions. For example, in region A, we can get information about the acceleration of the body. In region B, we can get the information about the speed of the body, and in region C, we get information about the deceleration or retardation of the body. Also in region A, we can get the distance covered during acceleration. Also in region B, we can get the distance covered during uniform velocity or uniform speed. And in region C, we can get the distance covered during retardation. Also, to get the total distance covered, all we need to do is to add up the distance covered in region A plus that of region B and that of region C. Alternatively, to get the distance covered, all we do is we consider the shape. For example, in region A, we can clearly see that A gives a right angle triangle. And as such, if we look at this, the formula for finding the area of a right angle triangle is simply half base times height. That is, once we get the information about the speed attained and the time taken to attain the speed, we can get the distance covered during uniform acceleration. In portion B, if we bring out from the velocity time graph, we have that B looks like a rectangle, And to get the distance covered during uniform speed or velocity, we simply say the distance covered equals the area of the shape, which is given by the length times breadth. That is, the velocity attained multiplied by the time it took to attain the velocity. So if we denote the velocity as L and the time taken as B, then we have that the distance covered during uniform speed is given by L times B. To get the total distance covered during retardation, we consider the portion C. And if we look closely, the shape is also a right angle triangle. And as such, we can get the distance covered by using area of the shape, which is half base times height. And the height, from previous example, we denoted it as L. And of course, the base, which is denoted as B, obtained from time, will just be half base times the height now we denoted as L. And that gives the area of the shape, and that gives information about the distance covered during retardation. To get the total distance covered, we say total distance covered distance equals sum of areas in region A plus region B plus region C. That is, we already got this as half base times height for region A plus length times breadth in region B and plus half base times length in region C. Let's take an example. Let's consider this question. A car starts from rest and accelerates uniformly for 5 seconds. It attained a speed of 18 meters per second. It maintains this speed for the next 10 seconds. This brake was applied and the car was brought to rest in another 2 seconds. Determine 1. The acceleration of the car. 2. The distance covered during acceleration. 3. Retardation of the car. And 4. Total distance covered. To do this, we shall make use of a velocity time graph as shown. We draw a sketch for the motion with this axis representing our velocity and this representing our time. And of course, V in meter per second. Let's take this. And of course, T into seconds. Now we have that the car started from rest and accelerates uniformly for 5 seconds. So let's take this as our 5 seconds. Then it moves. It attained a speed of 18 meters per second in the time interval. So here we have 18. And it maintained this speed for the next 10 seconds. So the next 10 seconds will be 10 plus 5, and this will give us 15. The brake was applied and the car was brought to rest in another 2 seconds. So in another 2 seconds, we have that 15 plus 2, that gives 17. And this gives the representation of the journey in terms of velocity time graph. We are told to get the acceleration of the body. In this case, if we decide to denote this portion as A, this portion as B, and this portion as C, we know information about acceleration will be gotten from portion A. And as such, the acceleration of the body is nothing but the change in velocity over change in time. That is, we are going to have this body moved from rest, that is, the initial velocity was 0, and it attained a speed of 18 meters per second. That means the final speed of velocity is 18. And it started from time 0 to time 5 seconds in the acceleration region. So we are going to have that acceleration A will be equal to change in velocity over change in time, which of course becomes V minus U over T2 minus T1, which of course will be final velocity attained was 18 minus initial velocity 0 all over the time interval was 5 minus 0. And this is going to give us 18 divided by 5. And this gives 3.6 meters per second square. And that is the acceleration of the car. So we were also told to obtain the distance covered during acceleration. And also we shall consider portion A. And of course we know portion A gives a right angle triangle. And so the distance covered during acceleration will be the area of the right angle triangle A. So that we have distance during acceleration, let's put it x sub A will be equal to half base times height, which will be half. The time interval, which of course is the base, was 5 times the height, which is the velocity attained, 18. And of course this will give 5 times 9, which of course will be 45 meters. So during acceleration, the car moved a distance of 45 meters. The question also asked us to get the retardation of the car. And to obtain retardation of the car, we shall consider portion C. And that is going to be the change in velocity over change in time. But in this case, the final velocity is going to be 0, while the initial velocity will be 18, since the body was coming from motion to rest, that is from 18 meter per second to 0 meter per second. So we are going to have retardation R will be equal to change in velocity over change in time, which of course will be V minus U over, let's call this T4 minus T3, which of course will be 0 final velocity minus 18 all over 17 minus 15, which is going to give us minus 18 divided by 2. Of course, we are going to have minus 9 meter per second square. And we ask ourselves, why is it minus 9 meter per second square? It is minus 9 meter per second square because the body is coming to rest, retardation. Also, we were asked to get the total distance covered by the car. And to do this, we can simply get individual distances in A, B, and C and add up. Or we simply get the area of the shape, which of course is a trapezium. And we shall do this as follows. Since we know that the shape is a trapezium, we are going to have that this portion here will be given, let's say A, then the total portion here, let's call it portion B, and of course we have this as portion H, the height, so that the formula for trapezium, the area of a trapezium, is given as area equals half into A plus B multiplied by H. And as such, we shall have for A 15 minus 5, which will give 10. For B 17 minus 0, which is of course 17. And for H 18. So we substitute and we shall have, let's use a clean board, so that total distance will be equal to half into A plus B multiplied by H, which of course will be half. We already obtained our A as 10, B as 17, and of course we know h as 18, which will be half multiplied by 27 times 18, which of course will be 27 times 9. And this will give 243 meters. So that the total distance covered by the car is 243 meters. As a recap, the velocity time graph can be used to obtain information about the motion of a body. Thanks so much for watching, and do not forget to subscribe. Click on the notification button to be reminded of our lectures. Thank you so much for watching.